slide we're supposed to start from, but we will start from it anyway, and if not, we'll find a different one. Do have several announcements. Goodness gracious, this is one weird week. Okay. I think I've said this to you before, just to remind you. If any of you go to the Birmingham West Campus, Leon Kennedy Center is now closed. Everything that was in Leon Kennedy is now in the new Academic Success Center. Big building. You have to find your way around in there to find all these places. I went to the police office last time. They went from, Leon Kennedy was good size, so a huge building. And the police went from a nice suite of offices to one little room. I said, they didn't like y'all, did you? They weren't happy. Okay. Coming up on the administrative calendar, couple things, but before we get to that one, let me hang on to that for a moment. Let me tell you again about the NCAS, which is NASA Community College Aerospace Scholars Program. The deadline for application is May 15th, so be working on that. It's a great program. Look into it. We've already talked about that one. Monday, yesterday, something happened on the Birmingham West Campus, I'm pretty sure, in the lobby of the Academic Success Center, the new building over there. There was a big ceremony of some nature that was a signing ceremony for the Alabama State University Transfer Memorandum of Understanding. I don't know all of what that means, but it sounds like it means this. If you're thinking of going to Alabama State, I think it just got easier. I think it's now very smooth and seamless to transfer from here to there. Always has been pretty easy, I think, but evidently they did something then. So that happened yesterday. And if any of you are interested in being the next Miss Lawson State, there is an interest forum coming up. There is an interest forum coming up on this campus at 11:30 this morning. Okay, and it goes till 1 o'clock. So if you're, let's see, this class goes, it's now 10 to 11:50. Yeah, you have time. Yeah, so you can still be there. And it's over in room 182, which I'm pretty sure is the testing center. If it's not, it's somewhere close to that. Room 182 in this building. Requirements are currently enrolled in Lawson State Community College, 3.0 cumulative grade point average or higher, completed and or currently enrolled in a minimum of 16 credit hours at least the 100 level and up, and active in an extracurricular activity or organization. If you want more information, Ms. Leslie Harper and Ms. Janine Jones are over on the Birmingham West Campus in the new building over there, and Ms. Kimberly Moore is her office is right across the door from the hall from the testing room. She's right there, so you can check with her. She'll probably be conducting the meeting today. Okay. And you've heard about this. Let me hit the other one first. Here, somewhere here. Well, no, I did. I thought I printed it, but I didn't. Okay. Full-time faculty will not be on campus at all tomorrow. Okay? We'll leave by 7:30 in the morning. We'll be on campus to leave, and then we'll be gone. We get dismissed down there. I think it's about 3:15. Figure a 2-hour trip back, maybe a little less, 5:15 or so will be when we get back. So we're going to be gone all day long. Okay, sorry about that. But it won't affect this class any. Good. All right. But Thursday, we do get affected. Honors and Awards Day is Thursday from 10 to 12. Okay, the people who have to be in it have to be there either at 9:30 or some as early as 9. So that means I have to leave by 9 o'clock to be there by 9:30 because they require us to be there by 9:30. So that means this class will not meet on Thursday. Sorry about that. In fact, classes are canceled from 9 until 12:30, I think is what they said. it's on there. Classes are to dismissed. To be dismissed is what they meant to say, from 9 to 12:30 for the purpose of attending the program. So if you have an 8 o'clock or 8:30 class, you'll probably only meet for 30 minutes, if that. Okay, if you have a 10 o'clock class like ours, we won't meet at all. 11:30 class is the next one. You may meet for the last 15 minutes. That's up to your instructor. But anything past 12:30, those classes will meet. So my 1:15 class will be meeting. Okay. Sorry about that. Okay. Now, the other thing that I printed off yesterday and found out it was wrong after I was announcing it in the class, or at least it appeared to be wrong, is the final exam schedule. Most of it's right, but they have finals starting on Monday, April 29th, whereas the academic calendar on the website says they start on Tuesday, April the 30th, and go through Monday, May the 6th, I think it is. And so something is in error. Either the academic calendar, which was approved by the chancellor's office, or, which I don't think that's wrong, or this is wrong. But it's only that one day. My guess is just going to move Monday the 29th to be Monday, May the 5th, or whatever it is, 6th. Well, there's another error here. It says all grades for mini-term 2 and regular terms must be inputted into, this is for us, not you, into the web suite system no later than 12 noon on Monday, May the 8th. Well, number one, Monday is May the 6th, and that's the final exam day. It should be Wednesday, May 8th, but on the next page, they say Wednesday, May 8th. So that should be correct. So it's an error on the previous page. So it's a lot of mess there. So I think that's most of what's coming up. Sorry about all the announcements, but you need to know. So at the end of class today, I will be telling you, I'll show you in the YouTube videos where to go to get the class for next time, okay? Because that's what y'all decided to do, if my memory's right, rather than try to make up the class just to watch it on YouTube video. Okay, so we'll see how far we get today, and that's how far we'll go. Oh, let me mark I should have marked this before I turned on the projector. The system. Caitlin is not here yet. Serenthia is not here yet. Jake's not here yet. Ryan's not here yet. Jemiah's not here yet. Christian is here. Top of the alphabet today. Congratulations. Okay. Jonah's here. Oh, we're on the roll now. Patrick's here. Bree's not here yet. Cody's not here yet. Demetric's not here yet. Ariel's here. Nancy's not here yet. Stephanie's not here yet. And I don't know, did I tell you last time Stephanie was in a pretty dangerous sounding car accident, but she's up and moving around. She has an appointment with her orthopedic guy today. She didn't have any broken bones or anything. Bruised really badly and very, very sore. So she was having to find out what's wrong with the shoulder. So she's not here today. Devin's not here, and Patience is here. Okay, that's 6. Enough for a volleyball team. And here's... No, you're in here. Don't hide. Goodness gracious, where are you? Jemiah. All right, so good number. All right. Let me turn on the projector. Okay. Jemiah, just a reminder, we do not have class on Thursday, okay, because we've got to be at award ceremony. And there are no, okay, let me say this again about the trip for tomorrow. Only full-time instructors are going to Montgomery tomorrow. That means if you have a class with an adjunct instructor, you do have class, unless you've heard differently from the adjunct. So please note that. The college is not closed tomorrow. It's only full-time instructors, and some of the administrators have to be in Montgomery all day long for an enormous waste of time. Okay, I've got that on the recording. So, okay, now, my memory is we had done example 1 and 2, and we're ready for the ambiguous case. So I don't know why this is set back here. Didn't we do all this? I believe we did. Yes, here's the ambiguous case. Any questions on anything so far? Administratively or trigonometrically, okay, or whatever. Okay. So, the side-side angle case is sometimes not that clear, okay? And they come up with a series of possibilities here. In example 1, we saw that 2 angles in one side always determines a unique triangle. Why? If you have 2 angles, you know the third angle, right? So if you know one side, then you can calculate the other 3 because you know all 3 angles. However, if 2 sides and 1 opposite angle are given, then you have 3 possible situations. It may be there's no triangle that fits those criteria, or it may be one and only one triangle exists, just like we had before, unique triangle, or you may have 2 different triangles that could satisfy the same initial conditions. So either no triangle exists, one exact one exists, or 2 different triangles exist. And here is the basis for those criteria. All right. Remember, we did from the very beginning, the height of a triangle is b times the sine of a. You have a here, b down here. These are angles A, B, and C. Then if there were an angle there, it would be b. So the height of the triangle, whether it's obtuse or acute, the height is going to be a times the sine of b. Always that. Okay. Now, the side opposite that A, angle A, is side A. If this side is shorter than the height, it's never going to reach the base, okay? So it can't work. That will be a no triangle exists. If A is less than the height, and the height being B sine A, okay? Now, if A is exactly equal to H, you have one unique triangle, so that's going to be a right triangle, because that is your height, okay? That will be, but it won't be a law of sines type situation, because that's a right triangle. In law of sines, we use that for oblique triangles, not right triangles. You can do everything you can with your right angles, right triangles. But if A is greater than or equal to B, it always is going to be one unique triangle, because A is greater than B. Okay? Certainly greater than H, but greater than B. Okay? Then you have one unique non-right triangle. Okay? This is one unique triangle that is a right triangle. This is one unique triangle that is not, that is an oblique triangle. But if A is something between H and B, if it's exactly equal to H, it's a right triangle. If it's greater than B, one and only one triangle. But if it's anything between H and B, then you could either have the A swinging over here or the A swinging over there. If it's between H and B, then you have 2 possible triangles. Okay. Now that's all with A being an acute angle. If A is an obtuse angle, if A is less than B, it's never going to reach the bottom, ever. So that doesn't work. Here it was A less than H. If it's acute, it's never going to work. If A is less than B, and it's an obtuse triangle, then it's never going to work. If A is greater than B, it always works. One and one unique. So A greater than or equal to B is 1 here. A greater than B will be 1 there. A equal to B is not going to work here either, because you only have a straight line. A greater than B, 1 unique, A greater than B here. So, one thing to do, if you know enough about it, but generally, your side-side angles, you're going to know B and A. Okay, so if the A is greater than B, you know there's going to be one solution. If A is less than B, you're not too sure. Okay, you could have two solutions, or you could have no solutions, or no solutions. If A is exactly equal to H, then you have a right triangle, and we usually aren't interested in those. So that's the situation. Okay. Here's a triangle. Okay, this is example 3. Yeah. Okay. And by the way, this example is also at larsonprecalculus.com to see an interactive version of this type of an example. So here's a triangle. A is 22 inches, B is 12 inches. Look at that. A is greater than B. This is going to make one unique triangle. Okay? So you have two sides, A and B. So that's the side-side part. Angle A, the angle opposite one of those two sides. It doesn't matter which one, opposite one of those two sides. Now, if this had been angle B, then this probably wouldn't work, okay? Because then you can't guarantee. So don't get too hung up on A and B. It's only if this is angle A does that rule work, okay? But it definitely works here, okay? So you know B is equal to 12 inches, A is equal to 22 inches, and the angle A is equal to 22 degrees. Guaranteed to work, okay? Now, how would you proceed to solve that? Find the remaining sides and angles. What would you go from first? Where would you begin? Second? Okay. You know the most information about A, so let me get my pen set up. You know the most information about A, so set up your law of sines with that. So A over sine A, okay, is equal to. Now, the question is, where do you go next? Okay? Well, you don't have a choice about C and Z. You know nothing about either one of those. So the only place that you can go is B over sine B. Only possibility. So what do you have there? Little b over sine B. Okay? So, filling in the blanks, this is 22 over the sine of 42 degrees is equal to 12 over the sine of B. Okay? Now, again, with our ratios and proportions, this is the thing we're looking for, so I like to isolate it. Sine of B is equal to the ratio we know, okay? So you're going to have to multiply by this. So here's how I like to do it to keep from being confusing. It's the product that we know, 12 times the sine of 42 degrees divided by the thing that goes with the part we don't know, divided by 22. The factor that goes out when you do your cross product. Okay? Now, they will do it, they will probably write it the other way, flip this over, flip that over, writing it that way, and then do sine B is equal to sine of 42 times 12 divided by 22, which is exactly what we did. So you can do it either way you want to, but it will work out being the same thing. So pull out your handy-dandy calculators, and let's see, where was it? It was in, I think, a physics class last week that someone got a bizarre answer, and I said, what mode are you in? And they said, oh, radian. Yeah, be sure you're in degree mode, or you're going to get a weird answer. That's what you get when you plug in those numbers. What did you better get when you plug in those numbers? Help me, somebody. Anybody? Anybody? Give me something. What do you get? You plug in those numbers.
0.
Second?
0.3649.
Fantastic. You got to get something between 0 and 1. Remember, the sign is always between 0 and 1. Could be between -1 and 1, but this is a triangle. We don't have any negatives in them, okay? So it's going to be between 0 and 1. And you did get that when you first said it. So what did you say that was? 0.26? 36. A few more digits? 49, blah, 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 right? Okay. Now, that's not very useful, is it? Until you do what? If that's what the sign of B is, what do you need to do to get what B is? Inverse sign. So take the inverse sign of whatever's on your screen. Don't take it off and then punch in 4 numbers. Use that whole set of numbers you have there and do inverse sign of that, and what do you get?
21.
B is equal to 21.4 degrees. I don't think we have the precision for that. I'm just going to say 21. But here's the deal. You know that since little b is less than little a, little b, or capital B has got to be less than 42. It sure enough is. I would settle for 21 degrees. I wouldn't do the 0.4, but I'm sure the book is going to carry around some extra digits. All right, where do you go next? You've gotten one of the 3 things you didn't know. You got one of the angles, angle B. Okay, where do you go from there? Anybody? Of course you can find the other angle. Once you know 2 angles, you know the third. And what would be the third angle? Okay, that would be 63. That sounds like 117 degrees. Oops, 21 degrees. I can't write. Okay. All right. 21 degrees. Now what? Say again? How do you do that? I found it. There it is. Okay. All right. Say again? Yes, I like to always use the ones we know. And so I'll go back to 22 is to sine 42 degrees as little c is to the sine of 117. Now, let me go back and tell you something. In writing down an answer, only go to the number of digits you allow. But frankly, when I wound up with this on my screen, with all those digits out there, I would have taken that, added to 42, subtracted that from 180, and gotten a 117, either point something something or 116 point something something. I would take that thing, and that's what I would do, the sign of that. And then, again, I like to go with the thing we're looking for, C, is equal to product we know, which is 22 times the sine of 117, or whatever that big, long, hairy number was, divided by the sine of 42 degrees. And that's an exact number. That's why we used it. Okay, see what that gives you. What are you expecting the answer to be? Something less than 12, something between 12 and 22, or something greater than 22? Why? That's the biggest, well, it's not a hypotenuse because it's not a right angle. It's the largest angle, the side opposite the largest angle has to be the longest side. Yeah. Something greater than 22. Do you get that?
Yeah, 29.29.
29.29. So I'm going to leave it as 29 inches. Because we don't really have enough precision to do the 0.29. All right, does that look reasonable? Yeah. The smallest angle is opposite the smallest side. The largest angle is opposite the largest side. Yeah, everything understood. And the medium angle is opposite the medium side. Okay. So it looks like it works. Okay. Y'all happy with it? Let's see what they do. Okay, started by doing sine B, and I told you they were going to do this. They flip them over so the thing they're looking for is on top. Okay, that's how they do it. Doesn't matter to me. I like it. Once you get the ratios in place, the one that you're looking for is equal to the ratio you know times the thing you don't know. Okay, so that would be sine B is equal to little b times sine of A over A. Okay, and that, plugging in the numbers, you've got them. So that's like we did. And they got B is equal to, now they didn't tell you, but you do the calculation, then you do the inverse sine of your answer, and that gave you 21.41 degrees, which you do not have that much precision anywhere else in the problem, so you really are not justified in having that. 21 would do fine. However, I'd use that for the next step, and which they do, and they get 116.59 degrees. And you could even use more digits of that if you want to. I'd write down the answer of 117, but I'd use all those digits to do the next calculation, which would then be the remaining side, and then they flip them back again, because now they are looking for C. Put this thing they're looking for on top here, and then this time the ratio you know. And again, like Seth said, always use the ratio you know, because that was given. You use the other ratios, you're using round off numbers, and you may be introducing more error that way. Okay? So you do this, and you get something close to 29 inches. So even using their extra 2 digits of precision, it doesn't give them any more precision. 29 is really all you can count on anyway. Okay? Does that make sense? So we've solved the triangle. Whoa! They did the easy one, the one that you do have an answer to, and then they skip some that you don't know the answers. Okay, so let's go back and do example 4. Okay? What if you had a triangle that told you A was equal to 15 feet, B is equal to 25 feet, and the angle A is equal to 85 degrees. Okay. Now, most of the time, at least at this point, you probably, I'm making a guess here, I'm making an assumption about you, and I may be wrong on this, but you probably are not willing to look at that and saying, that can't possibly work. Okay? Here's why I say that. 85 is awfully close to 90 degrees. Now, it is possible you could have an angle of 94 degrees, and that leaves another angle of 1 degree, I believe. And yeah, you can have an angle greater than this, but is that going to give you a side that's that much less? I don't think so. This is going to be awfully close to your biggest angle. My guess is going to be your biggest angle. And how can you have a side smaller than the big, than another side by that much? I mean, yeah, you can. Like I said, if your side B was 94 degrees, then your side C would be 1 degree, right? Okay. Not a very reasonable thing, but then A and B are going to be very, very close together. Not differing by 10 feet. Okay. No way. So I would look at this and say, that's not going to work. Okay. But you're probably not used to looking at them like that way. So what could you try? What is it set up for? A law of sines, right? So let's see what happens if we just blindly go about plugging it in. What did the law of sines tell you? Okay, 15 over sine of 85 degrees is equal to 25 over the sine of B. So we're looking for the sine of B, so let's isolate that. Sine of B is equal to the product we know, 25 times the sine of 85, divided by the element that goes with the thing we don't know, and that would be your 15. Now that's how I do it. You can do it the way the book does, flip them over and do that kind of stuff. Okay, punch it in and see what you get. What you get there? Ratio that you know to be. Anybody?
You get 1.6603.
1.6603? Is that what you said? Okay. Now you want to do an inverse sine of that? Why not?
It's greater than 1.
It's greater than 1. You know this can't possibly work. So this is what the type of thing you're going to get if you have one of those no solution situations. You're going to find something that's impossible. The sine cannot be greater than 1. If it was equal to 1, that would be 90 degrees. That wouldn't be an oblique triangle, okay? But this is way more than 1. No way this is going to work. If you try doing an inverse sine on that, what do you get? Undefined error, domain error, you have some sort of thing. Yes, that's not going to work. Stop right there, time out, no solution. Okay? That's pretty easy, right? You don't have to go through and figure out what your H is and is B between H and B. You don't have to do that. Plug it in. If you get an impossible situation, there's no solution. Okay? So, that wasn't too bad. Okay? There is a checkpoint there. You can do your checkpoint. But let's now go to the next one. To me, this is the pain in the neck case. Oh, I'm sorry. It's the two solution case. Okay. How does that work? Here we have A equal to 12 meters. B is equal to 31 meters. And capital A is equal to, now this time they do give you 4 digits, 20.50 degrees. Now, frankly, to me that's meaningless in real life because you only have 2 single digits here, 4 there. You can't use the 4. You can use them, but you can't give an answer any more than 2. We're going to pretend that we have 4 everywhere. That's 12.00 meters and 31.00 meters. We'll pretend that, so we can use 4 digits. Okay. Now, this one, there's no easy way to do this, okay? Because something's going to sneak up and bite you no matter what you do, okay? But why not let's get started and do this. How would you begin? If I hadn't said that, how would you begin? And what would that be? 12 over sine of 20.50 degrees is equal to 31 over sine of B. That's the only way you can begin. Okay? So let's go to town with that. That sine of B is equal to the product you know, which is 31 times the sine of 20.50 degrees divided by the factor you don't know, 12. Okay? And what do you get that to be? Anybody? 29. Oh, okay. I was going to say, boy, you're quick. Okay. What do you get?
904.
Okay. 0.904 and change, right? And then you do an inverse sine of that, and what do you get? B is,
64.7.
was that a 64? 64.7. One more. 8. Okay. degrees. All right. Now here is where you have to stop and put on the thinking cap. Okay? And here's what the deal with that is. Here we had a value, 0.904, and that gave you an angle that was something like this, right? You understand what I'm saying? This would be the angles, 64.78 degrees. Okay. But think of this. Over in this quadrant, this angle that's exactly 64.78 from 180 would have the same sign because the SIN sign is positive in the first and second quadrant, with that as a reference angle. So what you need to do then is subtract this number from 180. Okay? So 180, and here's the metric. 180 minus 69.78 degrees, for some reason the 7 is disappearing on me, is going to be 0.32? I'm doing it in my head, so I may be wrong. Second? Oh, it's 64. I can't read my own writing. Okay, so that's not that, is it? Didn't think that sounded right. Okay, so that's going to be 115 point. Is that right? Yeah. Okay. Now I say this. If you added these two together, if you come up with something less than 180, then you have a two-case scenario. Okay? If you added these two together and come up with something greater than 180, this is not a possibility. So you do this, okay, get what B is. You came up with a legitimate B. Get what it is, subtract it from 180, you get another possibility. If these two added together give you something less than 180, then you have a two-case scenario. This is 1B, this is another. So what you want to call this? BS, that may not be the best thing to call it, and BL for large. Large and small. Oh, you want 1 and 2, that might be better. We don't want any BS in this class, do we? Okay. All right. We'll do B1 and B2. That actually will work out better, I think. B1 and B2. Okay. And sure enough, B2 plus this is going to give you 135 something another, which is less than 180. So we do have a two-case scenario. Okay. Well, with a two-case scenario, you've got a lot more work to do. Okay? So you want to do case 1 first? Where would you go first in case 1? What would be the next thing you would find? Anybody? What's that? Yeah, the third angle. I was going to say this. That's Seth's answer. Okay, find the third angle. So if we have this is A and there's B1, add those two together, and what do you get? 85.28. Is that right? And subtract that from 180, and that gives you 94.72. Right? Again, I'm doing it in my head, so I may be wrong. Is that what you get? All right. So there's your first. And we're going to call that C1 because that corresponds to the triangle with B1 is its other one. Okay. Now, what can you tell me now? These are capital C1 and B1. So in the first case, we were given these two. You found that one. You now found this one. You got one more thing to do. What's that? Little c1. Okay? And what can you tell me about little c1? Anything? It's got to be bigger than A and B, right? Because the angle is bigger than A and B1. So little c1's got to be longer than 31 meters. So let's see what it is. How would we get it? Okay, I would again use, oh, I was wondering, where did that come from? Okay, that showed up there. Use the angle you know, the ratio you know, which is 12 over sine of 20.50 degrees, that's ugly, okay, is equal to C1 over the sine of 94.72 degrees. Okay, so your C1, the thing you're looking for, that little c1, here you come back again, is equal to the product you know, which is 12 times the sine of 94.72 degrees divided by the other factor, which is sine of 20.50. I hope that's right. Yeah, I believe it is. So punch that in and see what you get. See, we in the South, we're pretty violent. We punched our numbers in. I was told in Nebraska when we press buttons. We don't punch buttons. Okay. So never mind. What do you get? Anybody? 34. 34 point, well, that's 0.1 you said? Okay, I'm going to leave it 34 meters because we only had 2 C. And sure enough, this is longer than either one of those. So I'm happy with that. Okay. Doesn't seem like it's long enough, but that's long. It is. Okay. So there's our first triangle. It's an obtuse triangle. It's oblique, of course, but it's obtuse because you have one angle greater than 90. Okay. Then we go to our other case, which is also an obtuse triangle. That angle is also. So what have we got to do now? We've got A, B, and C. So what do we find next? I mean, we've got little a, little b, capital A, and now capital B2. So what do we go for next? All right, the other angle. Okay, so C2 is going to be, and we already did it, didn't we? Sort of. We added those two together, and we came out with 135.82. Subtract that from 180.00, and that gave us a 44.18. I hope. That's in my brain. Is that what y'all got? Anybody? Okay. Don't let the calculator slow you down. Okay. So there's your C2 is 44.18 degrees. Okay. Now, before we proceed further, well, what's the last thing we need to get? Anybody? Huh? Little c2. Okay, can anyone make a guess about what value this should have? If capital C2 is in between A and B2, then little c2 had better be between A and B. So it better be something between 12 and 31. Y'all see why? So let's see what we get and see if that matches what we were expecting. So little c2, I'm going to use the same ones up here except different numbers, of course. That would be the product you know, which is the sine of this capital C2, so it would be 12 times the sine of 44.18 degrees divided by 12. And you tell me what you get. Okay, a little louder. 20. Let's make it 24. Approximately 24 meters. Yes?
Where did you get that 135 to subtract from the CPU?
Okay.
I was practicing.
Here's my B2, right? And here's my A. Added those two together, you get 135.82, right? And then subtract that from 180, that's how you got your 44.18. Got it? And then we were guessing at something between 12 and 31. Hey, 24 is in between there, so I feel pretty warm and fuzzy about it. Okay. Don't know that it's right, but at least it's in the right ballpark. Okay. So there we solved two triangles. One with the small small b, B1, and one with the larger b, B2. And what you have to check is A and B1 had to be something less than, well, this is the B1. That is definitely a possibility. Then subtract that from 180, the reference angle of this, from there to get to the second angle. And if that thing plus A is less than 180, then we have a second. If that thing was greater than 180, hang it up, you already got the one. Okay? Does this make sense? All right, let's see how the book did. They came up with, oh, they used B1 and B2 too. Clever. I wonder where you got that. Okay. They came up with 64.78 as one C and 94.72 is the second C, with the little c being 34 meters for the first case and little c being 24 meters for the second case. Okay? So I think we got all the same answers. Believe we did. Any question? All right. There is a checkpoint. Well worth your effort to go through the checkpoint and see if you can figure that. Okay. If no questions, we'll move on to areas of an oblique triangle. Okay? Now, this really hasn't got that much to do with law of sines, except it's where we began everything. The procedure used to prove the law of sines leads to a simple formula for the area of an oblique triangle. If you remember that back in the day, we said the area of a triangle is 1/2 the base times the height, right? If that was a right triangle, you know what the height is, because that's the perpendicular distance, okay? If you can measure that. But with an oblique triangle, that height is not something that's really easy to determine. You can estimate it by trying to get the shortest distance that will reach that point from down there. But that's not an easy thing to get. But if you remember back how we began, that the height is b times the sine of a, or a times the sine of b. You know, either one. If you know the side here, c, okay, and you know either of those two angles there, you can get the height, and then 1/2 the base times the height. That's going to be. Now, even if it's an obtuse angle here, again, b times the sine of a. Well, here's a here, but here is its reference angle in the second quadrant, and that's still b sine a, okay? That would still work. Or A times the sine of B, you only have one choice here to get the H there too. So since that is your height and the base is C, then you know the area of any oblique triangle would be 1/2 the base, which is C, times the height, which is either B sine A or A sine B. Either one, okay? And that's what they give you right there too. Well, wait, okay. Not quite. If you flip around the angles inside, if you notice here, this is 1/2 B, C, sine A. So you have all three letters there, right? So as long as you have two AB sine C or AC sine B, that works too. Okay? I was giving the example of C times A sine B, which is of course those three. But even if you went to the other, use a different base, that works too. So that's the area of any oblique triangle. If you know two sides and the opposite angle, you know the area. But you got to know two sides and the opposite angle. Two sides in the same angle where you are in, yeah, that's not going to work. You need to know two sides and the opposite angle. Okay. So it's a little bit limited, but it is there. And it comes straight from our old thing, 1/2 the base times the height. Okay. So so here's the formula. The area of any triangle is 1/2 the product of the lengths of the two sides and the sine of their included angle. That's the angle in between those two sides. This is B and that's C. This is sine A, and this is angle A. If this is C, A and B, then the angle in between. So this is the included angle. 1/2 product of the two sides times the sine of the angle in between those two sides. Whichever side you have, BC sine A, AB sine C, AC sine B. Note that when angle A is a 90-degree angle, the formula gives the area for a right triangle. Of course it would, 1/2 the base times the height. I mean, whichever of those is the base times the height. Okay. Similar results are obtained for angles C and B equal to 90 degrees. So the sine of 90 degrees is 1. All right, any questions on that? So let's do example 6. Yes. Okay. Find the area of a triangular lot having two sides of lengths 90 meters and 52 meters and the angle in between those of 102 degrees. So here we have it doesn't matter which one you have long. I'll put the long one down here. This will be the 90 meters, the 52 meters, and the angle in between of 102 degrees. Now, mine's obviously not to scale, but how do you get it? What's the area of that triangular lot? Right? What does that give you? Frankly, I like to just do half of this or half of either one of those would be 26 meters. Okay. Get rid of the 1/2 up front. And then, well, you still have to do sine of 1 and 2, so it doesn't help much. Saves a little bit of punching in buttons. 26 times 90 times sine of 1 and 2. Or 0.5 times 52 times 90 times sine of 1. I don't care. What you get is an answer.
I got 2,289.
2,000 what?
289.
89. Okay. And that would be square meters. Areas and square meters, but you got meters times meters, so that's what it is. A sine always has no angles, no units for it. Okay, so you got that. Now, You might say, hey, you can't get 4 digits of precision out of 2, 2, and 3. So, yeah, you could say approximately 2,300 square meters. That would be legitimate, but I'm not going to mess with that. 2289 sounds okay to me. And what did they get? 2289 square meters approximately. And they have a checkpoint too. Well, not just that, we'll get to see how they did it. Okay? Consider A is 90 meters and B is 52 meters. The angle C is 102 degrees. Theirs is a little more precise than mine. And then the area is 1/2 AB times the sine of C. 1/2 of 90 times 52 times sine of 102, and that gives you approximately 2289 square meters. Good deal. All right, application as if we had just done an application. Here's example 7. What we have is a course for a boat race. It starts at point A up here and proceeds in the direction of south 92 degrees west. So you look to the south and then go 92 or 52 degrees to the west, okay, until you reach point B. Then at point B, you look south and go 40 degrees east. So you go back this way until you reach point C, which lies exactly 8 kilometers beneath A, directly south of point A. So approximate the total distance of the race course. Okay? Now, if you drew this out like they did, you see there's your 52 degrees. That's useful. This 40 over here is not really all that useful, is it? But we do need the 8 kilometers. But what do we do? How do we proceed? That 40 is outside the triangle. Any ideas?
Since the 2 lines are parallel,
Right? This one is that one. Perfect.
we can know that angle C is going to be the same as angle.
Yes, angle C is going to be the same as 40. That's called alternate interior angles. When you have 2 parallel lines and a transect, then the angles on the opposite sides of the transect interior are equal, as are this one and the one that would be over here, the one up here, and there. But then 2 alternate exterior angles would be equal too, but we're not dealing with that. So yeah, from this we know this is also 40 degrees. All right, and now that we've got that, what do? We need to know approximate the total distance of the race course.
Well, we have 2 things, so we can add them together and then subtract from 20.
Perfect. You add these 2 together, you get 92, and subtract that from 180, and you get 88 degrees there. And now you can use law of sines. Got it. And how would you do that?
A over sine of 52.
Okay. Oh, you said A. I thought you said 8. Okay. Let me do A. Okay. Say that again, what you said.
A over the sine of 52.
A over the sine. That's little a. And let's label them. This is little a. This is little b. See. This one is little b. Okay. A over sine of 52. Now I've got it. 52 degrees is equal to 8 over the sine of 88 degrees. Perfect. And then this is in meters, of course, kilometers, of course. Okay. So the product, A is equal to 8 times the sine of 52 degrees divided by the sine of 88 degrees. And what's that approximately?
6.21.
6.21 kilometers? 3.1. So I'm going around it to 6 kilometers. It said approximately. I'm going to approximate much more liberally or conservative. I don't know which one it is than they do. Okay. All right. Now what?
Do the same thing except for C.
Okay, do the same thing for C, right? So little c over the sine of 40 is equal to 8 over the sine of 88 degrees. Okay, so that makes little c equal to the product, 8 times the sine of 40 degrees divided by sine of 88 degrees. And what does that give you?
5.15.
Okay, approximately 5 kilometers. So what do we have the total race course being?
19.
Approximately 19 kilometers. You already knew the 8, add 11 to it, and that gives you 19. And when they carry it out to the extra digits they have, they get 19.46, which they may say is closer to 19.5 kilometers, but they don't have the precision to do that. Especially if you're in a boat in the water, you're going more than that anyway. You don't turn nice, sharp angles in the water. Okay. Good deal. Everybody see that? How we got it? Okay. And I think that's the last. Oh, let's see how they got it. Because the lines BD and AC are parallel, it follows that the angles, the alternate interior angles, are equal, or that symbol is congruent, I think is what that symbol is, meaning they're the same, they're equal. Okay, consequently, the ABC has the measures of 52, 40, and 8. You can calculate B to be 88, which is what we got using the law of sines. You got little a was 6.31 kilometers. Little c was 5.15 kilometers using precision you don't have. And then the total distance was 8 plus those 2. And that gave you about 19 kilometers. Good deal. All right. How are we doing on time? Oh, we got plenty. Okay. Let's do the vocabulary. And blank triangle is a triangle that has no right angle. Oblique, perfect. And told you it was a vowel coming up. Number 2, for triangle ABC, the law of sines is A over sine A is equal to what, which is equal to C over sine C? B over sine B, perfect. Number 3, 2 blanks and 1 blank determine a unique triangle. 2 angles on one side. If you got 2 angles, you know the third angle. Okay, so it doesn't. So 2 angles on one side determine a unique triangle. The area of the oblique triangle ABC is 1/2 BC sine A, which is the same as 1/2 AB sine C, which is the same as what? Same as what? What's the third one? 1/2 AC sine B. Perfect. So do homework exercises. I think I've already given you 5 and 7. Do those 2. They're both at Calc Chat. Do any of the odds 9 through 21. They're all at Calc Chat. 11's at Calc View. Do any of the odds 23 to 31. They're all at Calc Chat. 29's at Calc View. Do either 33 or 35. They're both at Calc Chat. 33's at Calc View. Do any of the odds 37 to 43. They're all at Calc Chat. 37's at Calc View. And do any of the odds 45 through 53. They're all at Calc Chat. So pick the ones you're most interested in, need to practice on, whatever. Then you have a couple of true-false, 55 and 57. They should be at Calc Chat. 59 is one of those error analysis I sort of don't like because they're showing you something that's wrong. And you say, figure out what's wrong with this argument. And then you can think about doing 61 if you would like. And let's move on to the law of cosines. We don't have a lot of time, but we do have some, right? Oh, yes, we got 8 minutes. Okay? So 6.2 is the law of cosines. This is coming up. All people here have received the third test, right? Okay, good. And I need some tests coming in while we're speaking of that. And I need some research papers coming in. So get those into me. You have very few weekends left in the term. Do you realize that? Okay. All right. So chapter 6 is additional topics in trigonometry. 6.2 is the law of cosines. So if you remember back, we had law of sines that worked with angle, side, angle, or angle, angle, side. Either one of those, law of sines works perfectly. If you know two angles and a side, you could use the law of sines. If you knew two adjacent sides with the angle opposite one of those two, you could use law of sines with that as well. But there were two other cases, three sides. There's no way you can use the law of sines. You always got to have a side with the opposite angle, okay? Or if you have a side angle side, which is exactly what we had in the area thing we just did with the angle in between, no way you can use law of sines there either, okay? So we'll use the law of cosines for those two. We'll use the law of cosines to model and solve some real-life problems. And then we'll come up with Heron's formula, area formula, which is another way to get the area of a triangle. And in this one, you don't need to know an angle. Because guess what? Measuring angles is not an easy thing to do, okay? If you have a protractor, you lay it on the ground, there's a lot of chance for a lot of error in that. But if you have tape measure, you can measure the three sides, and you can determine the area from that. And that's what Heron's formula allows. So here's the introduction. That blinking light can drive me crazy. Okay, almost give me a headache. Okay, two cases remain. The list of conditions needed to solve an oblique triangle. If you know three sides, no way you can use law of sines. Or if you know two sides and the angle in between, no way you can use the law of sines. So when you're given those two situations, side, 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 or side angle side, you get real sassy with it, then you should be able to. None of the ratios in the law of sines will be complete, so you can't do it. Such cases, you use the law of cosines. Now, what in the world is the law of cosines? If I said, what's that right there, what would you tell me? That's Pythagorean theorem. But it's not quite, because we're dealing with oblique triangles, not right triangles. So there are what they call the standard form and alternative form. And I don't know why one's standard and one's alternative. Maybe the standard was on one line, the alternative has two lines. I don't know. But here's how it goes. Pick a side, any side, a squared. That's equal to b squared plus c squared. The square of the other two sides added together, and then subtract from that twice b times c times the cosine of the angle opposite. Cosine A. And that works for all three of them. Pick b squared, that's a squared plus c squared, minus 2ac cosine b. Or c squared would be a squared plus b squared, minus 2ab cosine c. Now, that's if you have two sides with the angle in between. Notice here, side, 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 side. You have these two sides, the angle in between. These two sides, the angle in between. These two sides, the angle in between. That's for the side, angle, side situation. The alternative form, notice what you have on the right-hand side in all those. Just the three lines. What you do is subtract a squared from both sides, add the 2b cosine a to both sides, or any of those, and then divide by 2bc. So that gives you that one, that one, that one. So cosine a, the angle is that you are looking for, okay? This is driving me nuts. It's b squared plus c squared, not the angle one opposite you know. Subtract that one, divided by 2bc. Cosine b would be a squared plus c squared minus b squared divided by 2ac, the two that you know. two opposite that angle. Or if you're going for cosine C, a squared plus c squared, a squared plus b squared minus c squared divided by 2ab. Okay, so that's side, side, side. Say again? Yeah, this is side, side, side. This is side angle side. Exactly. Okay. Do we have time for an example or not? Huh? 1 minute left. So we'll use that 1 minute. We'll start this example 1. That's, yeah, I've got my mark there already. So let me tell you what to do for next time. Okay, I'm going to get out of this and out of that and go to Blackboard, because this is where you would have to go. So we did 6.1 and just barely got started in 6.2. So if you go to Blackboard, now I don't know if your Blackboard looks just like mine. Mine's the instructor version. My name doesn't spell right. Okay. However you get to Blackboard. Okay. Go to our course. Now I have a lot more courses than you do. I don't know if yours has this thing up here, but sometimes this is really, really slow. So I have to find our course, Math 113, Spring 1819. There it is. I know y'all are used to doing this, so you know how this goes, right? You use Blackboard all the time, don't you? Even on weekends. You use it daily. Okay. Never mind. All right. This tab here that's handouts, PowerPoints, and more. Okay. Remember, my syllabus is up here. My locator card is here. And then just about everything else is here. The PowerPoints, the research paper instruction, and the additional websites you might find useful. And there's YouTube videos right at the top. So click on that, and you'll see all the videos right here. Okay, syllabus, research. Remember, we used those from before. There's 6.1. We've already finished 6.1, so I'll delete this one. But here's the one you look at, 6.1 to 6.2. We've already done the last part of 6.1, so you look at these two, 6.1 to 6.2 and 6.2 to 6.3. Look at those two for next time. Okay. Today's, in fact, is going to be 6.1, 6.2. So I'm going to delete that one too, because we did this one. So the one you do for next time is 6.2 to 6.3. Okay. So you look at this one for next time. I'll delete those two others. And now, if there's one or two examples or something that doesn't get connected, you can read the book and get those in between. But that's the one you do for next time. We'll start next Tuesday with that one, 6.3. Okay? Good thing.
You won't be here Thursday? You won't be in class Thursday?
Okay, for your class, I'll be there from 8:30 till 9. Because I have to go to the honors program. Right. Okay, but this class, I'll not be here at all because I'll be at the honors program. So y'all do that, 6.1 to 6.2, and, I'm sorry, 6.2 to 6.3, and we'll pick up with 6.3 next time. Okay? Good deal. Okay.